This video is for 3.1 in the IB program or 8.1 in Secondary Math 3 Honors. I want you to go ahead and pause the video and write just those definitions down. I'm actually going to change the order that the notes are showing up in. So the definition of a sequence is an ordered set of objects. A finite sequence is a sequence with a limited number of objects. So for example, 1 or 0, 1, 2, 3, that has 4 objects in it. You could also list where you kind of have a gap. So 7, 9, 11, and then the gap, and then 25. So it's including a lot more, but it's still a limited number. Whereas an infinite sequence has an unlimited number of objects. So 0, 1, 2, 3, keep going. Basically, it's not terminating. The other thing I want to talk about is term notation. So to figure out, to kind of work with these to figure out what term it is that you're looking at, we use a subscript n, where n is the term number, not the term value. So if this is my sequence, then if I'm looking at my first term, because there's a 1 there, that value is going to be 1. If I'm looking at the fourth term, so 1, 2, 3, 4, that value is 13. And then if I'm looking at my 7th term, so 4, 5, 6, 7 is going to be right here. I'm going to have to figure out the pattern to figure out what would come next. So that would have been my 7th term. So to get to here, I'm adding 4. Add 4, add 4, add 4, add 4. So what do I get when I add 4 to 21? 25. So we represent what term it is that we're looking at and the value of that kind of place. So go ahead and make sure you have that written down. And then we're going to be able to write different formulas in terms of either what term are we looking at or using previous terms. So the explicit formula designates the nth term of the sequence as an expression of n. And the recursive formula designates the starting term, a subscript 1, because that's your first term, and the nth term in the sequence as an expression containing the previous term, which would be a subscript n minus 1, because it's referencing, hey, I want the term before it. And I think the baby's waking up. So, for example, if I said I wanted to use, let me see, if I wanted to use kind of what we were looking at before, then my first term is going to be that 7, and then each time I'm just adding 2. So the recursive formula for this would be, hey, this is your first term. The term you want, just take your previous term and add 2 to it. So that would be your recursive. So if I wanted my second term, I would take my previous term and add 2. If I wanted the third term, take your previous term and add 2. And that continues on. If I want to look at an explicit formula for this, that's actually going to be 2 times the number, or the term number, plus 5. And I'll show you why in a second. So I'm going to write this here explicit. So if I wanted the first term, you're plugging in 1. Well, 2 plus 5 is 7. If I want my second term, 2 times 2 plus 5 is 9. This one's nice because if I wanted, say, my 10th term, you just do 2 times 10 plus 5. Okay. Don't worry about where these numbers came from. There's a kind of a special way to figure that out, and we'll talk about that later. But that's the difference between your explicit and your recursive. Your recursive is always using previous terms, where your explicit is only using what term number is it. And then we're going to talk about how to use a graphing calculator with these. It's actually awesome that you can do this. So basically, I have to go get the baby. Go ahead and write this down.